In engineering, precision is everything. We build machines with micron-level tolerances because tighter gaps mean efficiency. But in the 1940s, a team of Soviet engineers inverted this rule entirely. They built a weapon that was intentionally loose. A rifle that rattled when shaken, with internal clearances massive enough to swallow sand, mud, and ice without skipping a beat. It was not accurate by modern sniper standards. It was heavy, and its ergonomics were primitive. Yet, it became the most manufactured firearm in human history, with over 100 million units tearing through modern geopolitics. Welcome to ERA Sentinel, and I am Ethan. Let us get into it. To truly understand why the automat Kalashnikov Model 1947 exists, we have to clear away a massive historical misconception. The AK-47 was not invented in a vacuum, nor was it a sudden stroke of isolated genius. It was born out of profound tactical trauma. During the opening stages of Operation Barbarossa in 1941, Soviet infantry found themselves completely outgunned. The standard-issue bolt-action Mosin Nagant was reliable, but in close-quarters urban combat, its slow rate of fire was lethal to the user. On the other side, German squads were deploying submachine guns like the MP-40, and later, a revolutionary concept, the Sturmgewehr 44. The StG 44 fired an intermediate cartridge, smaller than a full rifle round, but more powerful than a pistol round. It gave the individual soldier controllable automatic fire at real-world combat distances. Enter Mikhail Kalashnikov. He wasn't a career ballistic scientist. He was a wounded tank commander recovering in a hospital bed after the Battle of Bryansk. Listening to infantrymen complain about their submachine guns failing in the freezing cold, Kalashnikov started sketching. But the Soviet military bureaucracy didn't just hand him a factory. The road to 1947 was a brutal, multi-stage engineering trial. The Soviet Main Artillery Directorate issued a requirement for a completely new weapon system, utilizing their newly developed 7.62 x 39mm M43 intermediate cartridge. Kalashnikov entered the arena against established design titans like Vasily Degtyaryov and Alexei Sudayev. In fact, early iterations of Kalashnikov's design, known as the AK-46, were actually rejected by the testing commission for being too complex and unreliable. Defeat forced radical evolution. Kalashnikov, along with his chief assistant Alexander Zaitsev, completely redesigned the operating system. They tore down the AK-46 and engineered a philosophy of aggressive simplicity. This brings us directly to the mechanical soul of the AK-47. To understand why this rifle refuses to stop shooting, think of its internal mechanics not as a delicate watch, but as a runaway freight train. The AK-47 utilizes a long stroke gas piston system. When a round is fired, the high-pressure gas behind the bullet is tapped through a port near the end of the barrel. This gas slams into a massive piston head, which is physically welded directly to the heavy bolt carrier group. The entire assembly moves backward as one solid piece of heavy steel. Here is the secret. Most Western rifles of the era, like the early M16, focused on close tolerances to prevent dirt from entering. The Soviets knew dirt entering was inevitable. So, instead of blocking it, they gave the parts room to breathe. The clearance between the moving bolt carrier and the receiver walls is massive. If mud or carbon buildup gets inside the receiver, the sheer mass and momentum of the heavy bolt carrier group simply crushes the debris, scraping it out of the way as it slams closed under heavy spring pressure. Locking the chamber is handled by a robust rotating bolt with two massive lugs. As the bolt carrier moves forward, a cam slot forces the bolt to rotate and lock into the trunnion. It is a violent, raw mechanical cycle that prioritizes reliable cycling over everything else. Let's talk numbers, but look at them through the lens of actual combat. The AK-47 fires a 7.62 x 39mm round at a muzzle velocity of 715 meters per second. The cyclic rate of fire sits around 600 rounds per minute. Now, that muzzle velocity is lower than Western battle rifles of the same era, which were firing full power rounds like the 7.62 x 51mm NATO. This means the AK-47 has a significantly looping ballistic trajectory. Past 300 meters, the bullet drops rapidly, and accuracy degrades significantly. Furthermore, the heavy reciprocating mass of the gas piston and bolt carrier moving back and forth inside the weapon shifts the center of gravity violently during automatic fire. This makes muzzle climb notorious. If you hold down the trigger, the rifle aggressively forces its barrel up and to the right. But the Soviet military did not care about making a target rifle. Their statistical analysis of World War II combat showed that the vast majority of infantry engagements happened well under 300 meters. Within that envelope, the AK-47 was devastating. It offered massive terminal energy compared to submachine guns, with absolute battlefield reliability. However, early production was a manufacturing disaster. The original 1947 design, which we now call the Type 1, utilized a stamped sheet metal receiver to save weight and cost. But Soviet metallurgy at the time wasn't advanced enough. The stamped receivers deformed under the violent stress of the weapon's operation, causing catastrophic failures. To save the project, the Soviets had to completely reverse their manufacturing philosophy. They switched to the Type 2 and Type 3 variants, machining the entire receiver out of a solid, heavy block of forged steel. This made the rifle incredibly tough, but also significantly heavier and much more expensive to produce. It was not until 1959, with the introduction of the AK-47, the modernized automat Kalashnikov, that the Soviets finally perfected the stamped sheet metal process. The AK-47 reduced weapon weight by nearly a full kilogram and established the iconic silhouette we recognize today, including the slant muzzle brake to combat muzzle climb. This manufacturing evolution is where we must address the persistent historical myth. Did Mikhail Kalashnikov just copy Hugo Schmeisser's Sturmgewehr 44? Visually, they look like brothers. They both share a curved magazine, a top-mounted gas tube, and a pistol grip. But peel back the steel skin, and the internal engineering reveals two completely different design philosophies. The German SD-44 utilizes a tilting bolt system, where the rear of the bolt drops into a recess in the receiver to lock. It also relies on a breakdown hinge design similar to the modern R-15. The AK-47, conversely, uses a rotating bolt, heavily influenced by the American M1 Garand mechanism. Kalashnikov's genius was not inventing entirely new sub-mechanisms. It was the radical consolidation of existing mechanical concepts into a single, bulletproof platform optimized for mass production by low-skilled labor. And that optimization changed global warfare forever. The Soviet Union didn't just manufacture the AK, they turned it into an export commodity and an instrument of geopolitical leverage. Blueprints and tooling setups were shared across Warsaw Pact nations and allied states from China to Romania. Because the weapon was designed with massive mechanical tolerances, it could be produced in suboptimal factories with loose quality control. Yet, the finished product would still fire every single time the trigger was pulled. The legacy of the AK-47 is complicated. It is an engineering masterpiece of low-cost efficiency, a machine that democratized firepower. It allowed small insurgent forces to directly challenge modern, technologically superior militaries. It remains a testament to a specific design philosophy that in the chaos of real-world warfare, brutal simplicity and absolute reliability will always triumph over fragile sophistication.